Hey, I wanted to go over the definitions of machinery room. I had a situation about 6 months ago when two lead engineers came into my office claiming that the 100 machinery rooms we had at my facility that I manage, that somehow we weren't meeting international fire code requirements for gas detection. And that kind of took me back. But I was surprised by that statement. But I want to show you the definitions of machinery rooms, how to read between the IFC, IBC, and the IMC on this subject. Because as it turned out, we were perfectly compliant, but when you read the code, it would really surprise you. You'd think, oh, hey, end of the world type thing. Let me show you what the IFC says concerning this really quick. So if you go to the IMC, and I'm in the IFC, the International Fire Code, I'm in the 2018 version here. I'm using the 2018 versions because I'm in Idaho. That's where Idaho National Laboratory is located. And this particular code set is what we use at the location where I am the AHJ. So if you read this IFC section, section 605.8, it says machinery rooms shall be provided with a refrigerant detector with an audible and visible alarm. It's very straightforward. Mechanical refrigeration, if you have, and you'd assume, hey, mechanical refrigeration, that can apply to anything. I mean, any kind of refrigeration system. It provides no limits. Normally in the IFC, a lot of people don't realize, if you go to section 105 of the IFC, it gives you permit level quantities. That's the trigger to know if you need something like an NFP 704 sign or whatever it happens to be. But in this case, there's no indication of permit level quantities. It just says machinery room. Well, that's your cue, machinery room. It says machinery room here and also refrigerant. So if you go over and take a look at chapter 2, look up machinery room or refrigeration room or something. There's simply nothing here if you look at that. There's nothing to indicate that there's something bizarre with machinery room. If you go to the IBC, the 2018 International Building Code, likewise, there's no definition of a machinery room or a refrigeration room. But if you go to the 2018 IMC, it does define machinery room. And it just drives home this point that all the ICC codes kind of go together. You kind of need to look and examine them as a whole set, not just individually. But if you look at machinery room, and then it references 1105 and 1106, so if you go to chapter 11, jump over there, it gives you a definition right here, 1105.3. It requires refrigerant detectors in these machinery rooms as required by that section I just referenced in the International Fire Code. But still, it doesn't tell you what a machinery room is. If you go over to the beginning of section 1104, machinery rooms, what it says is all components containing the refrigerant shall be located either outdoors or in a machinery room, where it has this specific definition, where the quantity of refrigerant in an independent circuit of the system exceeds the amounts shown in table 1103. So there's your trigger right there. So you need to have this machinery room only where the quantity of refrigerant in an independent circuit exceeds the amounts shown in table 1103. So let's jump over to 1103 really quick, table 1103.1. I'm using R134A. I think it's worthwhile. I wanted to talk about this as well. And there's some grades here. Look at A1, A2, A3, B1, B2, etc. A1's fairly benign. So let's look back at R134A. What that tells me is, I could be exposed to 50,000 ppm. I'm allowed to have 13 pounds of refrigerant per 1,000 cubic feet. So a 10 by 10 by 10 room, that's 1,000 cubic feet. I'd be allowed to have 13 pounds per independent circuit in this room. And I think the principle is, if you have a leak in there, are you going to expose your personnel to greater than, an IDLH type environment, immediately dangerous to life and health? So in this case, this R134A, and if you look, oddly enough, if you look from an industrial hygienist perspective, OSHA type stuff, as far as your PEL, personal exposure limit, R134A is rated as a simple asphyxiant. It's not dangerous. In other words, look over here. If you look at this far right column, This is your degrees of hazard. This A footnote points to NFP 704 diamonds. But if you look in this column, a 200 is what R134A is rated at. So 200. And if you recall, the 200, it has to do with life, health hazard, fire hazard, and stability type thing. If you go to NFPA 704, you can see that. Now, what I'm saying though is based on this code, looking at the codes, if you don't have greater than 13 pounds of refrigerant in an independent circuit per 1,000 cubic feet of available space in your refrigeration room, you don't have to meet the stringent definitions of a machinery room. So as pointed out before, if you do meet that, in other words, for this particular example, R134A, if I had 14 pounds or 13.1 pounds of refrigerant per 1,000 cubic feet, then according to this section, section 1104 of the IMC, machinery rooms required by this section shall be constructed and maintained in accordance with section 1105 for group A1 and B1 refrigerants, and in accordance with section 1105 and 1106 for group A2, B2, A3, and B3. So I would simply go over to 1105 and take a look at how to design this. So machinery rooms general requirements, it goes through the general requirements for a machinery room here in terms of expected air change out, ventilation. You go through this, you can see all the requirements that you have. Now I mentioned before, A1 is fairly benign in terms of exposure limits. When you jump to an A2, A3, then you have special requirements you have to meet. But otherwise, in this particular example, and for us, we use just A1. We're going to use fairly benign, fairly employee personnel safe refrigerants. But I want to delve into a second issue. So just solve this issue. So there's no requirement. If you're, in our case, we had no machinery rooms, refrigerant spaces that had greater than this 13, in the case of R134A, greater than 13 pounds of refrigerant per 1,000 cubic feet of machinery room space. So we don't have an issue at my site at all. Didn't need this detection. So, I explained that to these two engineers, and, they went away a little embarrassed. But that's what you can see. If you don't have all the codes put together, it'd be very easy to make the mistake where you have this knee-jerk reaction, such as what I mentioned before when you initially look at this requirement for refrigerant detection in the IFC. Unless you knew to look at the IMC, you'd be freaking out on this. But I want to show you something else I think that's worthwhile. I've had issues with oversight complaining about NFPA 704 diamonds. Now, first off, I don't have the references up. I just want to explain this. If you go to Chapter 50 of the IFC, it says you need an NFPA 704 diamond if you're above the permit level quantities. Well, what's a permit level quantities? If you go back to Section 105.6, I'll just do that really quick in the IFC. So let's just jump over to Section 105 really quick. What 105 does is it gives you the permit level quantities. And what do I mean by permit level quantities? Any quantities in this section 105.6, it requires you to have a permit by the fire code official. So if you go through and look at the various stuff, there's 50, 46, something like that, individual line items here that you have to consider. And if you go to compressed gases, for instance, you have carbon dioxide, blah, 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 blah. The inert and simple asphyxiant, look at that. So 105.6.8 requires a permit, and well, let's just look at this. 105.6.8, compressed gases. An operational permit is required for the storage, use, and handling of normal temperature and pressure of compressed gases in excess of the amounts listed. Now, I'd have to go back and look at this a little closer if I was actually doing an analysis. But if this is a simple asphyxiant, as industrial hygienists would specify, R134A, then I'm allowed to have 6,000 cubic feet of this material before I have to have a permit. It's kind of like nitrogen, there'd be a lot there. Now, I'd have to look into this a little deeper. There may be some other things with a particular refrigerant. It's not as simple as asphyxiant, for instance. Some of them aren't. But what I'm getting at is you don't need an NFPA 704 diamond on the outside of a room or building until you exceed the the operational permit limits. And in this case, it's 6,000 cubic feet at standard pressure. So if you look here, it says you need a 200 for your NFPA 704 diamond. But if you look at this particular refrigerant, R134A, and I don't want to take your time to show you, but look at the SDSs for any of the refrigerants. They're pure substance. They widely vary in terms of the assigned NFPA 704 categories. In fact, for 134A, I recall in one case, I saw a health hazard of 4 in one of the manufactured specs from the same manufacturer for the same refrigerant gas. Go figure that one. So it's widely variable, and that's why NFPA 704 specifically says it's a subjective assignment, and that's why the AHJ has a lot of authority in terms of modifying what those values are. So oversight in this case came and said, hey, the SDS calls that 4 for refrigerant R134A. I said, well, let's look at this a little bit closer. You're dealing with small quantities. You're under permit level quantities. If you look at IMC, it's a 200. The reality is you don't have an issue here. So I just want to share that with you. I hope there's some benefit in that. A lot of confusion on machinery rooms, and there's a lot of subtleties in terms of things like that. And maybe I'll throw out some YouTube videos and show that to you. But this is just to help you, if you're an AHJ, try to manage things a little bit better. Hey, thanks for your time. Enjoy your day.